Alright, here let's have the next lesson. Now let's have the higher order DEs and the differential operators, operator D. Now, okay, we define this. Okay, we define this symbol dky is equal to the derivative or the kth derivative y with respect to x. Okay, wait, the meaning of dy is that dy is dy dx. Okay, observe that d is what you call an operator here. D is an operator. Okay, now d will simply mean what? Will simply mean d dx. And let's say d squared will simply mean second derivative of second derivative of a function with respect to x and so on. So you see, okay, when you say d squared y, okay, that will mean second derivative of y with respect to x. So this is operating on y. And when you say d cubed y, that is the third derivative of y with respect to x. Okay, so now let us have the expression a is a sub o dn plus a1 dn minus 1 plus and so on an minus 1 plus d plus an. Now this is called the differential operator of order n. So remember what is the meaning of d. Okay, d to the n, that is the nth derivative, okay, with respect to x. Okay, so again we call this expression as a linear differential operator of order n. So when it operates on y, then we say that ay is equal to ao nth derivative of y with respect to n plus a1 n minus 1 derivative of y with respect to x plus and so on an minus 1 dy dx plus any. Okay. Now the coefficients ao, a1, and an in the operator a may be functions of x. So okay. Now let's go on operations on differential operators. Now this is okay, these are the conditions when you say sum or difference. Okay, so if a and b are operators, then a plus minus b can be distributed as ay plus minus by. For a product, okay, a by can be what? Can be written as a times open parenthesis by close parenthesis. And for scalar product, we have what? Open parenthesis ka close parenthesis y is the same as k open parenthesis ay close parenthesis is equal to a close parenthesis ky, okay, open parenthesis ky close parenthesis. Now these are rules, and then we have some properties of differential operators. All right, these are the rule. Associative, just like in numbers, okay, this obeys the associative law, okay, or property. That means if you a plus open b plus c close is equal to open a plus b close plus c. For commutative, a plus b is the same as b plus a. But the commutative law is not general for multiplication. AB is not necessarily equal to BA. In general, in general, but AB and BA are the same if all the coefficients of A and B are constants. Now for the distributive, you can distribute here AB and AC, that's AB plus AC, and you can distribute it as AC plus BC, that is AC plus BC. And for the exponent, you see that if you multiply a to the m times a to the n, you just add the exponents, m plus n, and you raise it the power am raised to the n, that is amn. For exponent, okay, only what? Only addition and multiplication holds, okay? So, okay, let's have an example. Let's perform this indicated multiplication. Now let the operator m be equal to d plus 2 and n be equal to 3d minus 1. Find m, okay, quantity ny, okay, and n, open my, close. So this is what you do. Alright. Look at how this is done. So this is the original problem. Okay. M of open ny close is the same as d plus 2 times 3d minus 1y. Now that uh, observe that this can be distributed there. So you can distribute it there. So you will get what? Okay, d plus 2 and then 3dy minus y. Again, this d plus 2 can be distributed again. So look at how it was distributed. D is distributed to 3dy minus y. And 2 is distributed to 3dy minus y. That's why it's d times 3dy minus y plus 2 times 3dy minus y. And of course, this will give you 3d, okay, dy. Of course, you can take out the constant. Okay, minus, distribute it there, you have dy, 2 times 3 is 6 dy, distribute 2, that's negative 2y. And what is d of dy? Of course, that will give you 3 d squared of y. And then if you combine this negative dy plus 6 dy, that gives you what? 5 dy and minus 2y. And then we can express this already as, okay, get y out, okay, it gives you what? 3d squared plus 5d minus 2y. And then from the definition of the operator, this is the same as 3 second derivative of y with respect to x plus 5 first derivative of y with respect to x minus 2y. Now let's have this n of my. Okay, for n of my, okay, we write n first and then later on m. So n my. Okay, this gives you, okay, start with 3d minus 1 there, that is 3d minus 1 times d plus 2y there. Okay, the first step is distribute the y there for dy and 2y. So you will get 3d minus 1 and then dy plus 2y. The next step is you have to distribute 3d to dy plus 2y and negative 1 also to dy plus 2y. So you have 3d and then distribute it there. That's dy plus 2y and then distribute negative 1 again to dy plus 2y. And then, okay, distribute the 3d times dy and then 3d times 2 is 6 dy and then minus dy minus 2y. Now, what is 3d times t? That's the same as what? 3d squared y, 6dy minus dy is the same as 5dy and then minus 2y. And then, factoring, okay, of course, this will be the same as 3 times the second derivative of y with respect to x plus 5 times dy dx minus 2y. Now, if you notice, okay, this what? Okay, this is not necessarily the, okay, this is the same. I'm sorry. Because these are constants. The coefficients here are constants. Okay, so that m of ny is also the same as n of my, as is what? As is evidenced by this result. Now observe that if this, okay, if these are what? If these are variables, then this will not hold. This, okay, these two will not, alright, these two values will not be the same. Okay, uh, as we will have in the next example. Okay, let's have the next example. This time, we'll have what? We'll have a is xd plus 2. Notice that this is, okay, this is a variable, and then b is of course a constant, coefficients lang, and then we want a by and b ay. So first step is, okay, a by, that is our a is what? Our a is xd plus 2 and then d minus 1 and then y. Then distribute y, you have xd plus 2 times dy minus y. Then you have to distribute xd to dy minus y and distribute 2 to dy minus y. Okay, so distribute xd to dy minus y, you have xd times dy minus y, and distribute 2 to dy minus y, that is plus 2 dy minus y. Next is, of course, d of d, that is xd squared y, and then xd, of course, that is minus x dy plus 2 dy minus 2y. Okay, and you see that you can factor what? The 2 minus x here in this one, in this here. You can factor out here in this term, you can factor out the 2 minus x, and you get what? You get dy. Then, of course, this will now be written as x from the definition of the operator, second derivative of y with respect to x, plus 2 minus x, first derivative of y with respect to x minus 2y. Now, let's try b of ay this time. Your b of ay, start with d minus 1 and then xd plus 2. Y. Okay, so start by distributing y there. So you have what? D minus 1 x dy, okay, plus 2y. Then you will have to distribute d to x dy y plus 2y and distribute negative 1 to x dy plus 2y. So this is d of this one, x dy plus 2y minus 1 times x dy plus 2y. And then you'll have to distribute d to x dy and then distribute d to 2y, that's 2 dy minus x dy minus 2y. Now observe that this is now what? Okay, this is now a product. Okay, remember that the derivative of uv is equal to what? U dv plus b dx. This is a derivative, okay, of a product there. So next step is, okay, you have x times the derivative of dy, see, plus dy times the derivative of x. This is a product, plus 2 dy minus x dy minus 2y. Just write terms to term. And then, okay, simplify, that will give you x d squared y. Of course, what is the derivative of what? What is the derivative of x? Okay, what is the derivative of x there? So the derivative of x here is what? Is 1. That's why it's only 2 dy there. And then combine the 2 dy there, that's 2 dy minus x dy minus 2y. Okay, next step is, okay, you can combine what? You can combine the dy and the negative x dy, just factor, okay. Of course, this is dy plus 2 dy, that is what? That is the same as, alright, this 2 is 3 dy. Okay, and then if you combine, that's why you have what? 3 minus x there. And then you factor the dy and then minus 2y. And then of course you can rewrite this already as x, okay, by the definition of the operator, x second derivative of y with respect to x plus 3 minus x dy dx minus 2y. Now notice that these two Okay, these two now, here and here, right? This is no longer what? This is no longer the same. So basically, this ABY here is not necessarily or not actually equal to BAY if you have what? If you have an operator with variable coefficients. Now observe also that if these are just constants, then and then this will be the same, provided that we have only what? Numerical coefficients for A and B. Next, let's simplify this now. Xd minus 1 times xd plus 2y. What you do is distribute the xd to the xd plus 2 and distribute the negative 1 to the xd plus 2. So you have xd minus 1. Okay, distribute first the y. That's x dy plus 2y. And then distribute the xd minus 1 to x dy. Gives you what? Okay, gives you okay, this is actually uh, alright, distribute the xd to the xdy plus 2y. That's why you have xd and xdy plus 2y. And distribute the negative 1 to xd plus 2y. That's why you have, okay, negative xdy plus 2y. Okay, next step is distribute the xd to the xdy. You have xd of xdy, okay, plus 2 times xdy. Just take out the constants, minus xdy minus 2y. Again, this is a derivative again of a product. So you have what? X times the derivative of dy, okay, plus dy times the derivative of x. Just take the x there outside. And then of course just what? Just rewrite 2x dy there minus x dy minus 2y. Okay. Now what is dy? Okay, what is dx? This is already only 1. Derivative of x is 1. Of course, this is next step. Okay, x times x, and then d of dy is d squared y. Okay, and then plus what? Just distribute the x there. X times dy, that is what? Distribute the x times dy, that is x dy, and then what? And then you can combine these 2x dy minus x dy is only x dy minus 2y. Okay. Next is, okay, you can combine the x dy and the x dy there. We have 2x dy minus 2y. And you can rewrite this already in terms of the derivative form, that is x squared second derivative of y with respect to x plus 2x first derivative of y with respect to x minus 2y. Okay, now let's define now what is a linear differential equations of order n. Okay, any linear differential equation of the form, alright, notice that this is a sub ox the nth derivative of y with respect to xn plus a1x n minus 1 derivative of y with respect to x plus an minus 1x first derivative of y with respect to x plus an xy equals f of x is a linear differential equation. Now, this can be written in a denotation. Look, this can be written as a sub o, here is the same as dn, plus a1 dn minus 1, plus the last is an minus 1d, plus any is equal to f of x. Okay, let us classify now linear differential equations. The first is according to coefficients. So what can we say about the coefficients a or a1, an1, and so on? Now, if the okay, this can be with constant coefficients, meaning to say all aix are constant. So this This is a linear differential equation of constant coefficients. The 5, the 3, and the -2 are constants. Now, linear differential equation can also have variable coefficients. Here, at least one of the AIx is not constant. So in this case, xd squared minus dy, x here is a variable, and it's now considered as a linear differential equation with variable coefficients. Now, also according to function, okay? Now, if f of x is 0 in this equation, right here in this equation, or in this equation, if f of x is 0, then you call it a homogeneous linear differential equation. Look at this example. The right side of this differential equation is 0. Now, it is called a non-homogeneous linear differential equation if that f of x is not equal to 0, and and this could be some variables. For example, look at the right side of d cubed plus 3d squared minus 5d plus 25y. The right side is 4x cubed plus 2x squared minus 7, which happens to be variable. So it is called now a non-homogeneous linear differential equation. Okay. Now here we now go to solution of homogeneous linear differential equations with constant coefficients. Alright. For a given differential equation of this form, again, AOdn plus A1 dn minus 1 plus an minus 1d plus any equals 0, there is an associated polynomial equation in M called auxiliary or characteristic equation. So look, this is auxiliary or characteristic equation of the form. Now look how this is done. This is what? This is a sub o. Alright, this is a sub o and then m to the n, a sub 1, m to the n minus 1, an minus 1m, and an. This will be called auxiliary or what? Auxiliary or characteristic equation. And the solution of the differential equation will depend on the roots of this auxiliary or characteristic equation. So there are 4 cases. Okay, the first case is distinct real roots. Okay, for every distinct real root, let's say in the characteristic equation has m1, m2, m3, and so on roots. Now, there corresponds a solution of the form. Now look at how is the solution. This is c1 e to the m1x plus c2 e to the m2x plus c3 e to the m3x and so on until cn e to the mnx. Now the condition here is that m1, m2, m3, and so on must what? Must be real and distinct. Meaning to say, it should be real and what? Different with each other. The second case is you have real and repeated roots. Okay, for every distinct real root m repeated k times, there corresponds a solution of the form. Look at the solution. That is c1 e to the mx, and then c2x e to the mx, c3x squared e to the mx, and so on. It will depend on how many times m has been repeated. For example, it's been repeated twice, then you just have c1 e to the mx plus c2x e to the mx. If it is repeated thrice, then it is until what? Until c sub 3x squared e to the mx, and so on. Okay, the third case is distinct pair of imaginary roots. Alright, supposing okay, one of the a distinct pair of a distinct imaginary roots is m ak plus minus bki. There corresponds a solution of the form. Look at how it is formed. E to the a1x c1 cosine b1x plus c2 sine b1x plus, okay, e to the nx, you have what? You have cn cosine bnx plus cn sine of what? Bnx. It depends on how many imaginary roots are there. Alright, this will be best demonstrated by examples. Of course, there is the fourth case. If you're if the if the roots of the auxiliary equation has m equals a plus minus bi repeated k times, there corresponds a solution of the form. Look at how it is formed. This is e to the ax c1 cosine bx plus c2 sine bx plus okay, here will just be repeated. Okay, the next here is okay, the next here is what? E to the ax, e to the ax, and then there should be what? X now. Then c1 cosine of bx plus c2 sine of bx plus and so on until you reach this point there. Okay, let's have one example. Okay, let's call this example 1. Okay, let's solve 4y double prime plus 11 y prime minus 3y 0. Okay, the first step is get the characteristic equation, rewrite it in a differential operator form first. So this is 4d squared plus 11d minus 3y 0. Then replace d by m. So you're going to replace d by m. You have 4m squared plus 11m minus 3 is 0. Well, you can factor this. Okay, the factors are 4m minus 1 and m plus 3 is 0. Therefore, the roots are 1/4 and negative 2/3. So this will fall into case 1 where the roots are real and distinct. So you have until C1 and C2. So therefore, our solution is what? Y is just what? Attach this 1/4 x and then attach this negative 3 there and then x. You have C1 e to the 1/4 x plus C2 e to the negative 3x is y. It will not matter which happens to be first here because anyway this is just C1 and C2. Next example. Okay, so this is our example 2. Okay, let's solve y double prime minus 12y prime plus 36y 0. Replace that in, write it in differential operator form. So that is d squared, okay, minus 12d plus 36y 0. And see if you can what? If you can factor this, okay, by rewrite it first in terms of m. So replace d by m to get the auxiliary equation. And then, alright, this can be factored as m minus 6 times m minus 6 is 0. If you notice that 6 has been repeated twice. So this belongs to case 2. You have what? You have just start with C1 e to the 6x and then C2x e to the 6x. So there is both e but only C2 will be what? Will be linked, will be mixed with x. Now let's have the third example. The third example is, let's have this as third example, 3y double prime plus 4y prime plus 7y 0. Alright, rewrite it in differential operator form. Okay, you have what? 3d squared plus 4d plus 7y 0. Replace d by m. Okay, you have what? 3m squared plus 4m plus 7 is 0. Solve for m. Now you can use the quadratic formula. That's negative 4 plus minus 4 squared. Okay, minus 4 times 3 times 7 over 2 times 3. This simplifies to negative 4 plus minus square root of negative 68 over 6. Okay, this is a square root of negative number, so this is imaginary. Okay, this will now belong to case 3, where what? Where, look, this is your real part. Okay, this is your real part, the negative 2/3. Okay, the negative 2/3, this will be associated with cosine, be associated with uh, e, the e, I'm sorry, the e. Okay, this will be associated with the e, and then this value square root of 17 over 3 will be associated with the, with what? With the sine and the cosine. So look at the solution. Okay, okay, that square root of 17 over 3 is associated with the sine and the cosine, and then that negative 2/3 there is associated with the power of e. So this is our general solution. Y equals e to the negative 2/3 C1 cosine square root of 7 over 3x plus C2 sine square root of 17 over 3x. Or you can write that in decimal also. Okay. Okay, let's have another example. This is 5. We have okay, okay, y triple prime minus 6y double prime plus 11y prime minus 6y 0. Now reduce it into operator form. That gives you what? D squared minus 6d squared plus 11d minus 6y 0. Replace d by m to get the auxiliary equation. That gives you m cubed minus 6m squared plus 11m minus 6 is 0. And find the roots of this cubic equation. Alright, you can find the roots. You can factor this as m minus 1, m minus 3 times m minus 2 is 0. Now, if you want to review your synthetic division, okay, your synthetic division is like this one. Okay, write it as 1, negative 6, 11, and negative 6. And then possible factors are, or possible roots are factors of 6. You start with 1, and then here bring down 1. 1 times 1 is 1, add negative 6 plus 1 is what? Negative 5. Negative 5 times 1 is negative 5. 11 minus 5 is 6. Times 1 is 6, and then 0. So the remaining element here is m squared minus 5m plus 6 equals 0, whose factors are m minus 2 times m minus 3. That's why you get this m minus 1, m minus 3, and m minus 2. So these are the roots 1, 2, and 3. So okay, just plug it in. For case 1, c1 e to the x plus c2 e to the 3x plus c3 e to the 2x. Okay. Another example is this, what, y double prime plus y is 0. So okay, let's just erase this thing here. Okay. All right. Rewrite this in what? Rewrite this in operator form. So you have d cubed plus 1y 0. Replace d by m. So m cubed plus 1 is 0. And factor this. Okay, factor is m plus 1. M squared minus m plus 1 is 0. So the roots are m is -1, and the roots of this is, of course, this is imaginary. The roots are 1/2 plus square root of 3 over 2i, 1/2 minus square root of 3 over 2i. Now this will be a combination of case 1, roots are real and distinct, and case 3, roots are imaginary, distinct. So the solution applying case 1 and case 3 is y c1 e to the negative x. Now that 1/2 will be associated with e to the 1/2, and then just add c2 cosine square root of 3 over 2x plus c2 sine square root of 3 over 2x. Of course, this is our sixth example. Okay. Next is, let's have another example. This is the seventh example. Okay. Y double prime minus y triple prime minus y double prime is 0. Okay, so the auxiliary equation is, rather, the operator form is d cubed minus d squared y is 0. Now replace d by m, you get m squared times m minus 1 is 0. Alright, the roots are obviously what? Okay, for this m squared you have two roots, which is 0 and 0, and for m minus 1 you have 1. So you have three possible roots. This belongs to case 1, this is roots real and distinct, and case 2, real and repeated. So for the real and repeated roots, you have this one, c1 plus c2x, and for the distinct root, you have c3 e to the x. Okay, let's have another example. That is, this is example 8. You are now given in operator form d minus 3 times d squared plus 25y is 0. Replace this by m, d by m minus 3 times m squared plus 25 is 0. Okay, obviously one root here is real and the other imaginary. So the roots are real, 3, and then that's 5i and negative 5i. Now this will be a combination of case 1, roots are distinct, and another what? Case 3, roots are imaginary. So the solution for what? The solution for, okay, associated with 3 is roots are real and distinct. So it's real and distinct. Just c1 of the 3x. And then this is 5i and negative 5i. Therefore, there is no e. So it will be associated only with cosine 5x and sine 5x. Actually, there should be e to the 0x. There should be e to the 0x in this what? In this, okay, in the cosine 5x. It's that e to the 0x is what? E to the 0x is 1. So that's why this is only c2 cosine 5x plus c3 sine 5x. Next, we have now particular solution. Okay. Find the particular solution of y double prime plus y 5y prime plus 4y 0 with initial conditions y of 0 is 1 and y prime of 0 is 3. Okay, the first step is, of course, this is our differential equation. Okay, transform this into an operator form, d squared plus 5d plus 4y 0. Replace d by m to get the auxiliary or characteristic equation, and find the roots. Okay, you can factor this. This is m plus 1 times m plus 4 is 0, and the roots are -1 and -4. This will just be case 1. Okay, the roots are, okay, the solution is y c1 e to the negative x plus c2 e to the negative 4x. Now remember, you have to determine c1 and c2 because you are given conditions there. y0 is what? y0 is 1 and y prime 0 is -3. So, okay, substitute already the condition. Okay, so substitute the condition, that is when x is 0, y is 1, so you're going to plug it there. So that's why it's 1 equals c1 e to the negative 0 plus c2 e to the negative 4, 0. So the first equation is 1 is c1 plus c2. And the next step is find y prime because you need y prime there. So your y prime is what? Derivative of c1 it is negative c1 e to the negative x, okay, minus 4 c2 e to the negative 4x. And substitute the condition when x is equal to 0, y prime is negative 3. So you have negative 3 is negative c1 e to the negative 0 minus 4c2 e to the negative 4 times 0, or this will just see negative 3 is negative c1 times 1 minus 4c2. So this is another equation. Okay. Now we'll just have to solve it simultaneously, these two equations. Okay, to eliminate, okay, let's rewrite another equation. 1 equals c1 plus c2. This is another equation. Okay, so to get c2 then add, to get c2 then add, so you will get what? Add this, that is just negative 4 plus 1, so that's negative 3. Okay, and then negative 3 plus 1 is 2. So you get c2 is 2 thirds. And of course you can find also c1 by, okay, doing any method here. You can use the calculator or elimination or Kramer's rule or whatever substitution. You get the value c1 is 1/3 and c2 is 2/3. And then you can plug it in this equation because we know already c1 and here is c1 and c2. Therefore y is 1/3 to the negative x, that was plugged there, plus c2 is 2/3 e to the negative 4x. Okay.